Hello everyone, I hope you all are good and you all are practicing problems. Let us for now focus on this one. So what is said in the question? The rod of mass 3m is constrained to move in the vertical direction only. So we have one rod here and this is constrained to move in vertical direction. And how it is getting constrained to move in this way? By giving it some physical support. जैसे यहाँ पे जो ये line दिया हुआ है ना, basically it seems like there is some case covering under which is this rod, under which is this rod, and then this rod is touching this wedge. Okay, so it is something like this. Done it? Because if there is no casing, nothing of that sort, I mean it will also move in the horizontal direction. क्योंकि अगर आप ध्यान से देखो, there will be normal reaction acting between wedge and this rod, and that normal reaction acting on this rod will be in this direction, and this will have two components, one along the horizontal direction, another along the vertical direction. So this horizontal direction force acting on this rod will try to accelerate it in the horizontal sense, right? But here in the question it is said that it is constrained to move in the vertical direction only, means some physical support has been given to it such that it cannot move in the horizontal sense. It will simply move in the vertical sense. So first thing first, this one we need to understand. After that, we have a wedge of mass 4m that moves in horizontal direction, and this wedge will move in horizontal direction. Also in the question it is said that we don't have to consider friction anywhere. ठीक है, neglect friction anywhere is said. सो अगर आप वेज की मोशन की बात करो, इफ देर इज नो फ्रिक्शन, देर इज नो हॉरिजेंटल फोर्स अराइजिंग because of its contact with the ground, right? So no horizontal force, but this normal reaction will have reaction on this wedge, and this n acting on the wedge will have horizontal component and vertical component. So there is nothing to balance this horizontal component over here, and because of this it will what, it will accelerate in the horizontal direction. Vertically this wedge is not in motion, so vertically you will be adding up everything in such a way that net force is equal to 0. So this is the motion of wedge. Now let us talk about some more masses here. The slider S of mass 2m moves on a fixed horizontal rod. Okay, so here there is a rod, and upon this rod there is a slider, and this is moving. So one end of slider you can see is connected to this string, and this string is finally ending at this mass. Okay, so this is one string, and then this slider is also connected with another string which is supporting another mass m passing over the pulley, right? So if you consider, see here carefully, सबसे पहले आप देखो इस क्वेश्चन में हमारे पास दो स्ट्रिंग है, राइट? सो इफ देयर आर टू स्ट्रिंग्स, टू डिफरेंट टेंशन you will be writing. Tension always acts away from the body, so you will be, let's say in this string tension is T1. So in this string I'm saying sorry, tension is what? T1. This is one single string. And let's say tension in this string is equal to how much? T2. So tension over here is how much? T2. Done it? Now how their motion will be related? This is, I mean, going to be very interesting. जैसे आप देखो, if this slider is going to move in this case sense, let's say in this sense, in that case what will occur? आप ध्यान से अगर अगर आपको दिख रहा है ऐसा है ना, दिस इज लाइक दिस. सो इफ इट हैज मूव टू दिस पोजीशन, इन दैट केस दिस स्ट्रिंग विल बिकम लाइक दिस. डन, पुलिस फिक्स्ड. ओके, सो एक्चुअली यहाँ पे क्वेश्चन में ये चीजें ऐसे होनी चाहिए थी, पुलिस फिक्स्ड एक्चुअली. सो आई मीन दिस स्ट्रिंग लेंथ विल इंक्रीज, एंड फ्रॉम वेयर दिस एक्स्ट्रा लेंथ विल कम? इट विल कम फ्रॉम m, right? So as slider will go towards left, this small mass m will go up, right? And in that case this rod, since slider is going towards left, whatever string will get released from this region will fall here, and that will make this rod go vertically down. ओके, सो मोशन कुछ ऐसा होगा. अब देखो हमें लिखना है कंस्ट्रेंट, तो सबसे पहले आप एक काम करो. Let's say acceleration of this is am in the upward direction, and acceleration of this is as in this direction, and acceleration of this 3m mass is a in this direction. Let's talk like this. Okay, so am और as कैसे connected होगा? वैसे तो आप सिग्मा t dot एक्स करके डिस्प्लेसमेंट दिस इज इक्वल टू जीरो करके आप कंस्टेंट रिलेशन निकाल सकते हो, बट ये काफी इंटरेस्टिंग है यार। यहाँ पे अगर हम डायग्राम बनाकर अप्रिसिएट कर पाए देन दैट विल बी मोर ब्यूटीफुल आई वुड से, बिकॉज हियर यू आर नॉट सॉल्विंग क्वेश्चन इन द एग्जामिनेशन हॉल, हियर यू आर टू लर्न थिंग्स। सो आई विल रीड इट। अब देखो यहाँ पे सपोज कर लो ये एक्स डिस्टेंस आगे की तरफ बढ़ा, सो इट हैज रीच्ड ओवर हियर लेट्स से, and in that case this string will become this, and I'm saying this slider has moved in this direction by displacement x. अब आप देखो अगर ये स्लाइडर x चला है तो ये m मास ऊपर कितना चला है, that is what I want to know. So initial length of a string was this one, right? And finally if you see here, I mean this side how much length of a string is, initially it was this, finally this much has increased and this much length is coming from where, from this portion, right? Done hai? So by this length this mass m has moved in the upward direction. अब ये लेंथ का वैल्यू क्या होगा, लेट्स से दिस इज y, सो x by y यहाँ पे अगर आप लिखते हो, और रादर यहाँ पे मैंने परपेंडिकुलर ड्रॉ किया है, दिस एंगल विल बी 60 डिग्री बिकॉज इन द क्वेश्चन इट इज सेड दैट दिस स्ट्रिंग मेक्स एन एंगल ऑफ 60 डिग्री विद द हॉरिजॉन्टल, दैट इज गिवन इन द क्वेश्चन। आप यहाँ पे ध्यान से देख लो, so the mass m is making an angle of 60 degree with the rod, okay? So that is the case, so this angle is 60 degree, and if you see this thing it is like this, right? It is like this. Done hai? Ek second, give me some time. Let us draw it more accurately. It is like this, okay? So this is your x and this is your y. So, and this is your 60 degree. So y by x क्या होगा तुम्हारा? This is perpendicular, right? So y by x is cos 60 and that is half. So y is equal to how much? X by 2. Done है? So acceleration, अगर velocity आपको relate करनी है, velocity of m will be equal to velocity of s by 2 and acceleration of m will be equal to acceleration of s by 2. So this is how we have related acceleration of these two bodies. Now let us focus on how acceleration of this slider and this thing can be related. क्योंकि relate होगा because these two are connected via a string, right? So if you see here, if this let's take another diagram, if this mass has reached over here, ठीक है, so it has traveled a distance of, I'm saying x, so this much x length of a string is getting released, that will go where, that will go this side, right? So by x distance this rod will come down if slider is going towards left by x distance. So their displacement will be same, their acceleration has to be same. So I will say here a is equal to as. Again sigma t dot x से ये भी निकाल सकते हो आप easily. So again that is trick, you know. I have also discussed in previous videos, so I hope you people are aware of this one. So A is equal to A is. अब देखो और भी constant बचा है क्या? You need to look at things carefully. One more constant is left, and that is between this rod and the wedge. So इसको हम separately ऐसे draw कर लेते हैं. Let us talk about this. So in this question, it is said that rod is constrained to move in the vertical direction, right? Then it will have only vertical motion. So let's say its vertical acceleration, we have already taken that to be a, and that is equal to as, right? So मैं इसको AAC लिख रही हूँ, and let's say this wedge is going in this direction by acceleration a. Okay, so wedge का या फिर AW ले लो, AW is the acceleration of wedge. Okay, how this AS and AW will be related? अब एक चीज तो यहाँ पे constant है ना, that this rod and this wedge are continuously in contact, right? And if two things are in contact, then along the line of, I mean along the line which is perpendicular to their contact surface, their velocity, acceleration, displacement, everything will be same. क्योंकि ये समझना बहुत आसान है हमारे लिए, जैसे आप देखो यहाँ पे बॉडी A है, B है. If I say this A and B are moving together, what do I mean by this? I mean they are always in contact. First of all, I mean if they are together, it means along this line, which is perpendicular to their surface, along this line they will have same velocity, same acceleration, same displacement, right? If they are staying together. क्योंकि अगर देखो दोनों का डिस्प्लेसमेंट अगर इस डायरेक्शन में अलग होता है, then A and B will start getting separated. If they have relative velocity along this direction, they will start getting separated. हाँ, A के पास can have relative velocity in this direction and then also it won't get separated. Done है. That is why we are talking about one specific direction. That direction is we are taking along the line which is perpendicular to their contact surface. Okay, so this is this line. Along this line, their velocity, acceleration, displacement relatively has to be zero. ठीक है, यानी कि it has to be same. ओके, सो यहाँ पे कॉन्टैक्ट सरफेस, अगर कॉन्टैक्ट सरफेस से अगर आप परपेंडिकुलर बनाते हो, दैट इज दिस लाइन, राइट? So along this line, check for the acceleration of wedge and check for the acceleration of S. Sorry, rod. So इसका acceleration इस direction में क्या था? AS है, right? And this angle will be how much? This is perpendicular to this line and this is perpendicular to this. If this angle is 45, this also has to be 45. ठीक है? So along this direction, its value will be AS 45. ठीक है? Sorry, क्या लिख रही हूँ? This is sheer blunder, है ना? A is cos 45, right? And AW will have component along this direction. This angle is going to be how much? This is 90 minus 45, again 45, right? So this will be AW cos 45. And these two has to be equal, right? You can see like they're in same direction. Magnitude wise also they have to be equal, right? Then only relative thing will be zero. So आप यहाँ पे लिखोगे AS cos 45 is equal to AW cos 45 and that will give you AS is equal to AW. सो हमारे पास ना अब सारा कंस्ट्रेंट है। क्या क्या कंस्ट्रेंट है हमारे पास? देखो, एक्सेलरेशन ऑफ स्लाइडर इज इक्वल टू एक्सेलरेशन ऑफ दिस रॉड। ठीक है, दिस इज वन कंस्ट्रेंट। अनदर कंस्ट्रेंट इज दैट एक्सेलरेशन ऑफ दिस मास इज इक्वल टू एक्सेलरेशन ऑफ स्लाइडर बाई टू, and third one is that acceleration of rod is equal to acceleration of wedge. Magnitude wise, this thing we have got. Okay, so this is the constraint we have got. I hope I have written everything correctly. Yeah, ठीक है. So now is the turn of writing equation so that we can calculate thing. तो सबसे पहले चलो इसका लिख लेते हैं. नेक्स्ट स्लाइड ले लेते हैं. यहाँ पे लिखते हैं इसका. So if you write for this one, here I have taken tension to be T1 in this string. ठीक है, in this string I have taken tension to be T2. Done है? We have done that already, right? So this is T2. If you write FBD of this M mass, you will be writing what? In the downward direction mg, in the upward direction it is T1, and it has acceleration in the upward direction equal to am, which is equal to as by 2. So here I will be writing for this one T1 minus mg is equal to mas by 2. This is the first equation. Okay, अब देखो second equation. Let us write for this slider. It is moving in this direction. Done है. It has T2 force acting in this direction and tension T1 in this direction. It will have one horizontal component, that is T1 cos 60. So on this thing of mass 2m, forces acting in horizontal sense are T2, and here it is T1 cos 60. And since it is net moving towards left, left force will be greater than right one. So यहाँ पे आप लिखोगे T2 minus T1 cos 60, that is T1 by 2, equal to mass, that is basically 2m into as. Let us call this equation 2. इक्वेशन थर्ड अगर आप लिखते हो, रॉड पे क्या क्या फोर्सेस लग रहे हैं वर्टिकल डायरेक्शन में, बिकॉज वी आर टॉकिंग अबाउट वर्टिकल एक्सेलरेशन, राइट? सो इट इज गोइंग डाउन बाय एक्सेलरेशन एस ओनली. डन है. व्हाट आर द फोर्सेस एक्टिंग? T2 is acting. Done है. 3 mg will act in the downward direction, and then this normal force that was acting will have a component in the vertical direction also. Done है. And what will be the value of that normal component along vertical sense? N cos 45, right? So this angle is 45. So n cos 45. अगर मैं rod को यहाँ redraw करूँ, so in vertical direction it has forces acting T2, and then it has in this direction n cos 45, and in the downward direction it has only single force that is equal to its weight, and that is 3 mg. So it is going down with acceleration how much? as. So net downward force has to be greater than upward. यहाँ पे अगर आप equation लिखते हो, what you will be writing? 3 mg minus T2 is sorry, एक और force लिखना है ना? Let us write that. So that is minus n cos 45, n by root 2, equal to how much? Equal to that is, yeah, 3 m as. This is equation third. अब एक काम करो, आप इक्वेशन 1 2 3 को ऐड कर लेते, ऐड करके एक एग्रीगेट वैल्यू ले लेते। सो इफ यू ऐड 1 2 3, यू कैन सी हियर T2 will get cancelled, and 3 mg minus mg will become how much? 2 mg, and T1 minus T1 by 2 will become T1 by 2, and then this is minus n by root 2, and this is equal to how much? Add all these things. So 3 plus 2, 5, 5 plus half, that is going to be equal to how much? Yeah, how much? 3 plus 2, 5, 5 plus half, right? So 11, 11 by 2 MAS. This is what we have got, right? Now we need to calculate this value of n. That we can do very easily because we know this wedge has an acceleration of AS in this direction. And on this wedge, in this direction, what is the force acting? It has a component of n acting in this direction, and that n component is how much? N, this angle is 45, so n cos 45. So you will be writing here n cos 45, that is n by root 2 is equal to mass into acceleration. So 4 ma is. अब देखो n by root 2 किसके बराबर है, इसको इक्वेशन 5 ले लो, 4 ma is. So this was equation third. Equation third में आप n by root 2 का वैल्यू पुट कर दो, that is 4 ma is. So 2 mg plus T1 by 2 is equal to 11 by 2 plus 4 ma is. If you add it, you will be getting 19 by 2 MAS. Now let us focus on this one. Okay. So now we are done almost. So 2 mg plus T1 by 2 is equal to 19 by 2 MAS. अब देखो T1 का वैल्यू हम पुट कर सकते हैं फ्रॉम इक्वेशन 1. T1 इज इक्वल टू हाउ मच? mg प्लस MAS by 2. सो यहाँ से आप लिख लो 2 mg plus MAS by 2. ठीक है, एंड दिस by 2 अगेन. सो 19 by 2 MAS. आप एक काम करो, m को हर जगह से हटा लो because it is getting cancelled, and then you can see here what you are getting. This is 2g and there is half g, so that will become 5g by 2, and this is how much? AS by 4, so 19 by 2 AS plus AS by 4. So multiply, okay, plus है या minus? Minus होगा, sorry. डन है. सो दिस विल बी माइनस. नाउ लेट अस मेक द डिनोमिनेटर सेम. सो 2 से मल्टीप्लाई कर रही हूँ, दिस इज 2. सो वी आर गोइंग टू गेट 37 AS by 4 and this is 5G by 2. So from here we are going to get value of AS. AS is how much? That is your 10G by 37, right? So if we have got AS, we have got everything in sort, right? Now let us focus on what we were asked to calculate. So AS is 10G by 37. चलो आगे बढ़ते हैं and then we will try to see. Okay, just give me some time. Okay. So we have got A is equal to 10G by 37. Let us read the first thing. Net force on the block of mass M at this instant. So the instant, I mean the moment it was released from rest. So after getting released from rest, its bodies will have acceleration, the one that we have indicated already in the diagrams, and we have solved it. So we have to talk about net force acting on this mass M. So इस पे net force क्या लगेगा? Mass into acceleration, right? So it will have net force acting in this direction, and in this direction it was having acceleration as by 2. So net force on first body will be equal to how much? That will be equal to its mass into its acceleration as by 2, that will become 5G by 37. So this is 5 mg by 37. Yeah, that is correct. Okay. Net force on the wedge. अब wedge का भी आप देखो, यहाँ पे इस पे vertical direction में तो कोई force नहीं है, right? Because everything is balanced, because it is not moving in the vertical sense. Horizontally it was moving with acceleration as. Again net force क्या होगा? On 4m mass. Mass into acceleration, right? So 4m into as, right? So that is 10g by 37. So 40 mg by 37. Yeah. That is also correct. C को अगर आप ध्यान से देखो, contact force between wedge and the rod is what? So contact force अभी अभी हमने निकाला था, that was how much? If you remember, n by root 2 is equal to 4 MAS. So 4 MAS we have already calculated, right? That is equal to how much? This much. And n by root 2 is equal to this. So n will be root 2 times this, which is not definitely reflecting over here. So this is wrong. Tension in the string between blocks having mass m and 2m, that is it is asking what will be the m and 2m, right? So यहाँ पे इस ब्लॉक का भी मास 3m इंडिकेटेड था, सॉरी दिस वाज 2m एक्चुअली, ठीक है, वी हैव टेकन 2m ओनली क्योंकि यहाँ पे 2m लिखा हुआ है, ठीक है, by mistake that has happened, I'm really sorry. So tension in the string between blocks having mass m and 2m is how much? So between m and 2m क्या होने वाला है? So we are getting asked the value of T1. आप T1 का value निकाल लो. So we have equation over here, right? This is the equation. Put the value. Put the value of A is here, and you will be getting the value of T1, and that is not actually equal to the value that is reflecting over here. जो यहाँ पे reflect हो रहा है. So this is going to be also wrong. Done it? I hope you have understood this system. If you have understood really, then it's sorted. I mean, इस question में कुछ नहीं था, तीन चार चीजों को एक साथ mix कर दिया था, and that is why it was looking a bit bulky and bit. I mean, it was trying to scare us, but it's not that complicated, I would say. You just needed to be clear of how many strings are there, how many constant equations we can write, and if one body is moving up, then how motion of other bodies will get guided. It was that simple, okay? So I hope you have understood. But if you have doubt anywhere, you can always let me know in the comment section. Thank you. Bye bye. Take care.